About 4.5 billion years ago, our planet Earth was born. This was a time of cosmic chaos, where the universe was still young and full of raw, untamed energy. Imagine a swirling cloud of dust and gas, remnants of an exploded star. These remnants floated through the vastness of space, carrying the building blocks of future worlds. Gravity pulled this material together, spinning it faster and faster. As the cloud spun, it began to collapse under its own gravity, drawing more and more material into its center. Over millions of years, the cloud flattened into a disk, with the sun forming at its center. This disk, known as the solar nebula, was the birthplace of our solar system. The remaining dust and gas clumped together to form the planets, including our own. These clumps, called planetesimals, collided and merged, growing larger and larger. Early Earth was a hot, molten ball of rock, constantly bombarded by asteroids and comets. These impacts brought not only destruction but also essential elements and compounds. This period of intense heat and impact is known as the Hadean Eon, named after the Greek underworld, Hades. It was a time of fire and brimstone where the surface of the Earth was a hellish landscape. It's hard to imagine now, looking at our vibrant planet, but this was Earth's violent and chaotic beginning. Over time, the surface began to cool, and the first solid crust formed. Yet, from this inferno, the stage was set for the emergence of life itself. The very conditions that made early Earth so hostile also provided the ingredients and environment necessary for life to begin. The Hadean Eon was a time of intense heat and volcanic activity. Named after Hades, the ancient Greek god of the underworld, this period was marked by a hellish environment that was far from hospitable. The Earth's surface was a molten landscape with temperatures soaring and volcanic eruptions being a common occurrence. The surface of Earth was a magma ocean, constantly bombarded by asteroids and comets. These celestial bodies, hurtling through space, collided with our young planet, adding to the chaos and heat. Each impact brought with it not just destruction, but also the seeds of future life. These impacts delivered water and other volatile compounds to the early Earth, which would later become essential for life. The water vapor released from these collisions began to form the first rudimentary atmosphere, a protective layer that would eventually support life. During this period, a Mars-sized object is thought to have collided with Earth in a cataclysmic event. This colossal impact was so powerful that it ejected a significant amount of debris into space, altering the course of our planet's history forever. The debris from this impact coalesced to form our moon. This new celestial body began to orbit Earth, influencing its gravitational field and playing a crucial role in the development of stable environmental conditions. The moon's gravity stabilized Earth's rotation and created tides, which would later play a crucial role in the evolution of life. The rhythmic ebb and flow of tides began to shape the early oceans, creating environments where life could eventually thrive. As Earth cooled, the magma ocean solidified to form the first continents. These landmasses emerged from the fiery depths, providing the first solid ground on which future ecosystems would develop. The atmosphere was still toxic, composed mainly of carbon dioxide, nitrogen, and water vapor. This thick, noxious air was inhospitable to life as we know it, but it was a crucial step in the planet's transformation. But slowly, the stage was being set for the next chapter in Earth's story, the emergence of life. The volatile compounds and water delivered by comets and asteroids, combined with the stabilizing influence of the moon, were creating the conditions necessary for life to begin. The Earth was on the brink of a monumental transformation, one that would lead to the rich tapestry of life we see today. Around 3.8 billion years ago, our planet was a vastly different place. The Earth was a hostile environment with volcanic eruptions, meteor impacts, and a toxic atmosphere. Despite these harsh conditions, something remarkable happened. The first signs of life emerged on Earth. These were not complex organisms but simple single-celled entities that would lay the groundwork for all future life. These early life forms were single-celled organisms similar to bacteria. They were incredibly small, yet they held the potential for all the diversity of life we see today. They thrived in the harsh conditions of the early Earth, obtaining energy from chemicals in hydrothermal vents and volcanic hot springs. These environments provided the perfect conditions for life to begin and evolve. This marked the beginning of the Archean Eon, a time of significant change for our planet. During this period, the Earth's crust cooled, and the first continents began to form. These early life forms, known as prokaryotes, were incredibly successful. They multiplied rapidly, adapting to various environments and paving the way for more complex life forms. They diversified and spread throughout the oceans, laying the foundation for all future life on Earth. The oceans became a cradle of life, teeming with these microscopic pioneers. The Archean witnessed a crucial development, the evolution of photosynthesis. This process allowed some prokaryotes to convert sunlight into energy, a revolutionary step in the history of life. Some prokaryotes developed the ability to harness energy from sunlight, releasing oxygen as a byproduct. This not only provided them with a new energy source but also began to change the composition of the Earth's atmosphere. This event would have profound consequences for the future of Earth and the evolution of life as we know it. The increase in oxygen levels eventually led to the development of more complex life forms, setting the stage for the incredible diversity of life that would follow. The Proterozoic Eon, spanning from 2.5 billion to 541 million years ago, saw a dramatic transformation of Earth's atmosphere. Photosynthetic organisms continued to release oxygen, gradually filling the atmosphere and oceans. This great oxidation event had a profound impact on life. Many anaerobic organisms, unable to survive in the presence of oxygen, perished. However, this event paved the way for the evolution of aerobic organisms, which used oxygen for respiration, a far more efficient way to generate energy. This led to the development of more complex life forms. The Proterozoic Eon also saw the formation of the first eukaryotic cells, which contained a nucleus and other membrane-bound organelles. This marked a significant leap in complexity and set the stage for the evolution of multicellular organisms. Section 5. The Paleozoic Era. An explosion of life. The Paleozoic Era, beginning about 541 million years ago, marked a dramatic turning point in Earth's history, the Cambrian explosion. In a relatively short period, life diversified at an unprecedented rate. The oceans teemed with a dazzling array of creatures, including trilobites, brachiopods, and the first vertebrates. This era witnessed the evolution of plants, which colonized the land and transformed the barren landscape. Insects took to the skies and amphibians emerged, venturing from water to land. The Paleozoic ended with the Permian-Triassic extinction event, the largest mass extinction in Earth's history. Despite the devastation, life persevered, setting the stage for new creatures to evolve and dominate the next era in Earth's history. Section 6. The Mesozoic Era, the Reign of Reptiles. The Mesozoic Era, beginning 252 million years ago, is often called the Age of Reptiles. Dinosaurs, evolving from reptilian ancestors, rose to dominate the planet. They diversified into a spectacular array of shapes and sizes, from the mighty Tyrannosaurus rex to the long-necked Brachiosaurus. This era also saw the evolution of birds, descended from feathered dinosaurs. The first mammals, small and nocturnal creatures, also emerged during this time, living in the shadows of the dinosaurs. The Mesozoic era ended with another mass extinction event, likely triggered by an asteroid impact. This event wiped out the dinosaurs, along with many other species, paving the way for the rise of mammals. Section 7. The Cenozoic Era, the Age of Mammals. With the dinosaurs gone, mammals took center stage. The Cenozoic Era, beginning 66 million years ago and continuing to this day, is known as the Age of Mammals. They diversified rapidly, evolving into a wide range of forms to fill the ecological niches left vacant by the dinosaurs. During this era, grasslands spread across the planet, leading to the evolution of grazing mammals such as horses and deer. Primates, the group that includes monkeys, apes, and humans, also evolved during this time. The Cenozoic Era has witnessed the rise of human civilization and our profound impact on the planet. Section 8. The Future of Earth. Our planet's destiny. Earth has undergone dramatic changes throughout its 4.5 billion-year history. From a fiery birth to the emergence of life, from mass extinctions to the rise of human civilization, our planet is constantly evolving. What does the future hold for Earth? While we can't predict the future with certainty, we know that Earth will continue to change. Plate tectonics will reshape continents, climate will fluctuate, and life will continue to evolve. The choices we make today will have a profound impact on the future of our planet. By understanding the forces that have shaped Earth throughout its history, we can make informed decisions to ensure a sustainable future for all life on Earth. Section 9. The importance of understanding our past. Studying Earth's history is not just about understanding the past, it's about shaping the future. By looking back through time, we can learn how our planet has responded to change, how life adapts and evolves, and how our actions have consequences. Earth's history is a story of resilience, adaptation, and interconnectedness. It's a reminder that we are part of a vast and ancient web of life, and that our actions have ripple effects throughout this web. By understanding our planet's past, we can make informed decisions to protect its future. The more we learn about Earth's incredible journey, the more we appreciate the preciousness of our planet, and the importance of preserving it for generations to come.